We have a lot of sick classmates. One, especially Iron, emailed me this morning asking me what was going on in class today, so I told him I'd give him the video. If you're sick and you want to make sure that you stay up to date and you have trouble finding the video, email me. I'll send you the direct link. So Iron, our homework today is 2934. Feel better soon, dude. All right, so today we're still discussing one variable expression, but now we call it one variable inequalities. What is an inequality? What does that mean? What does in, that stem, mean? Alex? Not, right? So these are not equalities. Which means they're not equal, right? We've been using the greater than or less than comparison symbols. So we've used these comparison maths to talk about which side's bigger. Right? This time, we're going to actually find values for the variable that would make these statements true or not. We're going to test when the statement falls apart. So Maria's been recording her work to see which side of the expression Matt is greater, but she didn't quite show her work. So Garth comes up and he's like, hey, I don't quite get what you did going from step to step. So we got to explain how she got from step to step. So if we think about this as Mat A, Mat B, right, so she started with 5x, a positive 2, a negative 6. Over here, 2x, positive 2, negative 8. What did she do going from step 1 to step 2? We'll use cards this morning. We haven't shuffled in a while. Let's shuffle. All right, Marvin, you can kick us off while I shuffle. Yeah, what do we call that? Combining blank blank. The numbers can be added or can be subtracted. What are those called, Alan? Like terms, right? So she combined like terms. So please make sure that we all see she took the 2, added with the negative 6, got negative 4. She took the 2, added with the negative 8, got negative 6. Please make sure we recognize that. So between step 1 and step 2, all she did was combine constants, combine those like terms. Nathan, what about going from step 2 to step 3? There's a change on both sides, but she didn't show how she did it. Don't do that right now. So what changes? Does the constant value or the variable value change from step 2 to step 3? The negative 4 stays negative 4. The negative 6 stays negative 6. Ooh. The 5x turns into a 3x, the 2x. So both sides are changing, right? We're doing stuff on both sides. What did she do? Penelope? You know what she did on both sides? The negative 6 stays between step 2 and step 3. So guys, remember, between step 1 and step 2, if we think back to the vocab we've been using, she made 0 pairs. Right? When we add those positives and negatives and they cancel out, that makes 0 pairs. But when we take something off of both sides that was the same, what do we call that? What type of pairs?
Balanced pairs?
Balanced pairs. What disappears from the right side? 2x. What does she do on the left side? Take away 2x. So this minus 2x is balanced pairs, right? She's taking away the same thing from both sides. So balanced pairs, we're taking away the same thing from both sides, or both maths. And then what happens, Kate, between step 3 and step 4? You can even just tell me just what changes. You don't have to know how, but you can pass off if you want to. You know? I know. No? Aubrey? You know what we do between step 3 and step 4? What changes or how we get there? Ooh, what on? You know? Too close. We end up from negative 6, we get to negative 2. your hand up?
Yeah. Taking -4.
We take away -4, but taking away a negative is like adding. Right? So if we say take away -4, we can also think of that as adding 4. Again, balanced pairs, doing the same thing on both sides, but we kind of did that, right? We took away 4 negatives, and if we take away 4 negatives here, we get to -2. Any questions on what just happened? Because we're going to be doing that on our own then. This is just a review of what we did. This is also a reminder why we should show our work. If Maria had done this on a test, now we're getting to the point in the year where I'm going to ask you, like, how? How did you do that? Did you look at your neighbor's paper and write down what they had? Or do you actually know what you're doing to get from step to step? No questions. Okay, let's look at 24. Now, I don't like how this looks on the screen, so please make sure you realize that 1 is with the expression. So we are comparing, and I'm going to give you guys time to do this. We're going to write both of these out. We're comparing the mat with 2 plus 2x plus -3 with the mat that has 2x plus -4 plus 1. Simplify those out as far as you can using the 0 pairs rules and the balance pairs rules. Try to figure out which inequality symbol should go in between. Which one is bigger? You want to combine like terms. If you have like terms on the same side, you want to add those together. You need to move terms to get them together. How do we do it? If you're totally stuck, Ashley Park, if you're both totally stuck, raise your hand, please. You don't have to use tiles, but that's helpful. If you forget how to do this, I would grab some tiles. Emily, without doing a whole lot, what can I do on both sides pretty easily?
I'm guessing there's a reason why there's numbers highlighted.
I'm guessing that too.
You would add the like terms.
Yeah. If there's like terms together on the same side, add those together. So remember, we got right side versus left side here. We're kind of split by colors. We have a 2 and a -3. We have 2 positives, 3 negatives. We make a couple 0 pairs. What are we left with? Anyway, yeah. -1, right? Because there's 1 more negative. So that now becomes 2x and a -1. Or you could just write -1 if you want. But if we're writing out like tiles, we've got 2 x's and a -1 tile. On the right side, Annika, what do we end up with there when we combine the like terms? So does the x have any like terms? Like the 2x, are there any other x values? No, so the 2x stays 2x. -4, +1, which one has more tiles? the negative, right? So I've got a positive 1, 4 negatives. I make 0 pairs. What do I have left? -3. There's not really any work to show between the steps because we just combine like terms. The only work would really be highlighting or noting somehow that these are what combined. But now there is going to be work to show. So Grant, I need to keep combining like terms, but now it's harder. You know what I need to do?
You can
I guess combining like terms is kind of the wrong way to say it, maybe.
use 0 pairs.
We can use 0 pairs, or we can use balanced pairs, right? We kind of already did our 0 pairs on each side. If we're going to try to do stuff to both,
I used the wrong term, balance.
yeah, we want to use balanced pairs because we're doing something on both sides. What are you doing on both sides?
Circle, make an arrow, going away of the 2x.
Ah, now I love it. Grant said, put a circle on the 2x, take it away, take it off my mat. Now we're going to start to work on writing this out algebraically. So please make sure that you have this written out with me. And if you want, some people like to do like a dotted line down the middle. We've got left side versus right side. We are now going to take away the 2x from both sides. So we write that as a minus 2x from both sides. We are doing that. We're removing balanced pairs. Mr. Smith said he showed you the Indiana Jones video. So he was trying to remove something to replace it with the same thing, didn't work. If we have a system that's in a relationship and you take something off one side, you gotta take the same thing off the other side. Otherwise you mess up that relationship. Now what am I left with, Grant?
You're left with, on the left side, -1, and on the right side, -3.
So now I have -1 versus -3. Which side is greater? The left side, because higher up the number line. Now, is there any confusion in which side's greater here? Like, can somebody back up why Grant said we know that for sure? Patrick?
Because if you do the balance pairs of 1 and 3, just take away 1 from the left side, take away 1 from the right side, and 0 and -2, and 0 is big.
Yeah, we could even, and we could actually like add 1 to make that 0. You're saying take away a -1, but you're right. So take away the -1, we end up with 0 being greater than -2. And is there any doubt of what these values are? Is there any like, oh, we don't know for sure? There's no variables, right? These are numbers that we know. Up here, numbers that we're not quite sure of, right? X, we're not certain what it is. So, if we end up with variables at the end, that can make it slightly challenging to make those determinations. Check out 625 with you and your partner. You've got mat A and mat B shown here. Try to simplify, make 0 pairs, remove those balanced pairs. Please stick with a hand if you're confused. You've got 2 teachers in your help here. I'm going to highlight the main goal you're working towards, but don't just dive towards that. You want to do some work before you get there.
since they are see-through, you can't change the color. So you have to use the two different tiles. You figured it out, right? Make sure that you're writing it out like, so we want to get used to comparing this to that, like left to right, with them like having a symbol in between. So careful with that, like, what are you using that for? Yeah, a slash in math means division. So we want to start to be really particular. Don't use a symbol for something that is not meant for. In math, that slash would mean divide. So right now you wrote 2x plus 2 divided by x plus 5. Yeah, so be careful. I would modify that.
What expression do I get for the left side of my mat? Matt, your card is up. What's the left side? And it actually gives it to you in part B. That versus my right side. Alex? Well, that was that one. You guys are quick. So what's my right side to start? Yeah, just a positive X tile and 5 positive tiles. Francesca, is there anything that I can do on either side before I start working with both sides together? Not yet. I mean, I could, but we don't want to jump there yet. There's something I should do first. You're right, but we're just not there yet. Alan?
There's a negative tile on the left side, so you could do like
0 pairs, right? If you're working physically with the mat, this tile and this tile can make a 0 pair. So we can combine the 3 and the -1. We're really just adding. But 3 plus a -1 makes 2. So those get combined together. And my right side is still the x plus 5. Now, Francesca, I'm going to come back to you. What are you doing? I thought you told me to take 1x away from this. Why? What is that called? We're removing what type of pairs? Balanced pairs, right? Those of you like chatting with your partners, I hope you're verifying stuff because we're driving through this like really well. We're going to remove balanced pairs because I have 1x over here and that's easy to get rid of. I'm just going to remove 1x from both sides. Now that leaves me x plus 2 and 5. And I kind of really like this line down between. Now, do we know which side is bigger? Read part D. Look at part D. Sorry, part C. Delaney?
I have a question. Why is the 2x minus x? Why isn't it not 1x?
It is. So we don't have to write it, but every x that is by itself, do I have to say 1 Delaney? I have to say like, all right, 1 Delaney, what's the answer? As opposed to like, so when we talk about something and we assume quantity, we assume one of it, right? Like I want an apple. I don't have to say I want 1. Like I don't always quantify 1. So when we just say x, we know that's 1x. So there's really a 1 there, a 1 there, a 1 there, and a 1 there. We just don't have to write it. If you want to, do it. That's totally fine. It's assumed quantity of 1. So, does that make sense?
Yeah.
We are told mat A is greater than mat B. Right? They tell us that. Mat A is greater. What you're being asked to do is figure out how to make that true. What should I do next? Maybe we should have asked this question before we went to this part. Delaney, your card's actually up. Now, do you know what to do next to get my x alone? And again, like you said, this is actually 1x. Yeah, what do we do?
Subtract 2 from A and then subtract 2 from 5.
Yeah, what kind of pairs is that? Balanced pairs gets me to x greater than 3. You and your partner groups send one person up here, choose a color and a dot. What one? Hey, stop. You don't even know what you're doing.
I really like this dot thing.
You have to put it on your nose and spin around in a circle. Place it on the number line with what you think x should be. Now, talk with your group first. You get one dot for your team. If you're alone, if you're sitting alone, you can just come up and place a dot wherever you think.
Oh my god. Has to be 4 or above.
I physically cannot. No, I'm sorry. I do not. I could give you like 18. But I'm not. I said I could.
Can't be in the negative.
Terminology. So I got in an argument with my friends online about something mathematical. No, like my actual friends. We were online. They posted something and tagged me in. Those are my real friends, of course. This is how we used to do it back in the good old days. We make friends in real life. About using an exclamation point for grammar versus mathematics. Actually, a mathematics.
Go with your butt. No way.
12 factorial. Yeah. You can look it up. It's really interesting.
iPods are. Oh, shit. No, I don't want to. 7 on 1.
Wait to see how creative you are. Hey, we can pull that down, Alex. We got you, dude. Well, think inside the box. What?
Wait, was that like a clue or something?
Not really. It wasn't like a play on words.
What's it?
I disagree with one of these.
Is it the blue all the way that way?
One blue, well, depending. So these dots are tough. And I made this argument at a CPM training, and I think people are starting to get annoyed with me. But I said, well, where's the number? Right? If we go the dead middle of the dot, one of these blue dots is not quite true. Now, a few of you, we've got like a green dot, a yellow dot, a red dot, are way out here at 10. Somebody who told me 10, raise your hand and tell us why. There's 3 dots. It could be Kate.
It's just a number greater.
What do you mean? What?
It could be any number.
But I thought x has we're just looking for x's value. What do you mean it can be any number? Why? What's your argument? I need support. I need evidence. Okay, now be careful. X represents a number. X itself is a variable. I totally agree with that. But you said it's not a number. It isn't, but it represents a number that we're looking for. My question is it a number? They're telling me it's a bunch of different numbers. Patrick?
So, x is greater than 3. That's the term. So that means it has to be 4 or above.
How can I prove this, though?
Because it says right there, because it says x is greater.
Yeah, but we found that. I don't totally trust that. How can I check this? How can I prove this? How do I test it? Put in a where? What do you mean? If I put it in here, we found this. We'd just be testing what we found.
Like make x a random number and test what happens.
Test what? Where? Go back to the start and test it. So we go back to the beginning because we hadn't done anything here yet, right? If I erase this 0 pair, plug in whatever number you guys chose, whatever you marked up here, and somebody marked like 2.8, whether you were meaning to or not. You probably maybe were meaning to mark 3. But plug in whatever number you had. If it was 4 or 5 or 7, or test it. If this is like 5 and 5, 10, 11, 12, 13, take 1 away, 12. Is that bigger than 5, 10? Yeah, that works. Plug it in and check it. What's up?
Sorry to interrupt you.
Can I be quieter?
Tagging it.
Well, either one of you. I know.
Give me a holler if you can. So, here's what's up. To not keep circle talking and spending any more time on this, the big thing to realize, and I have 7th graders every year who say, well, I plugged it into what I plugged it in and checked it. I think the answer is 5, and I plugged it in right here. Well, guys, if you made a mistake here or there, or it'll still hold true because this is wrong if you made a mistake anywhere. To check your answer, you got to plug it into the beginning. Okay, to check if what we did is right, plug it in way back where we started. So, is there a number that goes too far? So our number line up here goes -10 to 10. Is there a number that goes too far? I want you to figure out how you could express this, let's say verbally, what values we can use for x. Talk with your partner. I'll give you like 90 seconds how you could talk about what is acceptable for x and try to write it out. Try to actually write like what we would say for x is or x can be. What would you say? When you're done with that sentence, write draw a quick number line. Anyone want to volunteer? I won't use cards here. Anyone want to volunteer for your sentence, what you wrote, how you would explain this to somebody? Alex?
I wrote that x has to be greater or equal to 3.
X has to be greater or equal to 3. So if we check this, say that's what you told me, and I want to make my life easy, so I'm like, well, that's kind of confusing. You said or equal to 3, so I'm going to try 3. So I say, all right, this is 3, so 6, 7, 8, 9, minus 1, I get 8, 3, 4, 5, 6, 7, 8. Is this true? So was your statement true? I think so. Gentle with the sad trombone. Now, Alex actually made things more complicated. You're ahead of where we are. Right now, we're not using the or situation. We just have to choose. Is it equal or is it more? We don't do the both. 8's not greater than 8. This is not true. So what we found out in our solution and what we would say verbally is x has to be greater than 3. So can x be 3.0000000000001? Is that bigger than 3? Can x be 3,008,600,042? 8 billion, 6 million, I don't remember. But I can't remember. So, what we have found is what we call a boundary point. Everyone in your notes, write down boundary point, please. And the definition for this is the limiting. I thought that was easier than restricting. Slightly less writing. The limiting point or points. So if you don't know how to do this yet, we're going to put an S in parentheses. The limiting point or points. It could be 2. For the value of a variable. Tiny bit modified from what the book tells you, it's the same gist. So what we do with a boundary point, and if you didn't do it yet, please draw this number line in your notes. Boundary point can be shown to us. It's a whole lot easier than explaining it. So mathematically, what we write, but how we show that on the number line, we put a point at 3. Right, because we're referencing 3. Now, Patrick, do you know what I do after that?
You would, you put like a little arrow and you put it like an arrow going up and you go to the right because it could be anything.
You put it going up.
So
Like up to the right, you mean?
Yeah, go to the right, yeah.
Now, when I said put a point, do I fill in that dot? Why?
Because there's like 2 types of like alligator sort of things, remember what they're called. There can be one that says that's greater than, and then one that's greater than or equal to.
So this, and we want to make a note in our notes, please. 3 is not, I'm going to make that all caps. 3 is not included. Here, the boundary point is not allowed. But like Patrick said, if the boundary point was allowed, I'm going to do something, I'm going to undo it. So give me your eyes for just a minute. Your eyes, you can pause writing. If we had the or equal symbol, then we would shade this in and shade out to the right because 3 would be allowed to be a point. But we just found out it's not. We can't in this situation. Not that. I want to go back steps. Yes, got rid of it. So here, 3 is not included. Our values have to be bigger. Does this make sense, how we showed it? Anything shaded is what's allowed to be the x, which is why we can't keep shading all the way because 8 billion is really far away. So this arrow includes 8 billion, 600 million, whatever number I said, and all of the other numbers. Yes. So if we had a biggest, an upper bound, this is our lower bound, right? Because then we start going up. If we had an upper bound, we might have another boundary point that would stop us. Questions? Wunderbar. So try this. Figure out what values for x make this true. And now I'm going to start writing all in one color and just putting my operations that I do on both sides. I'm going to do that in a different color to notate. Try this. If you get this answer, then graph it. Graph the result on a number line. First thing we should be trying to do is get constant values combined with constant values, variables with variables, if possible. Sometimes we have to get them off one side to get them on the other. Emma, what's the first thing you want to do? agree. Why are you thinking do something with 5? Yeah, if this is my split, and I look left side, right side, variables, constants, only constants. So if we want to isolate the variable, get that guy alone, we got to get rid of this 5. How do I get rid of positive 5? Subtract 5 or negative 5. Yeah, I could put 5 negative tiles, make a bunch of zeros, or subtract 5. So I could either say minus 5, or if you want, add negative 5. It's the same thing. So if I add a negative 5 over here, I make how many 0 pairs? Remember, we have to do the same thing on both sides. So these all make 0 pairs. 5 0 pairs, wonderful. How many 0 pairs do we make over here? Anybody? 3. What do I have left? Negative 2. So now I have 2 times my x value. Remember, that's multiplication. Is less than negative 2. Ella, if we have 2 times what we want, how could we get what we actually want? Well, this is tough, because if you were doing the actual tile math, this would be hard to think about. It's hard to hear you, actually. So imagine that we have 2 x's. And they're being compared. Sorry, those would be shaded in. My shaded x's. Those are being compared to 2 negative 1s. How could I get my situation just down to a single x? I have 2 of what I want, right? Cut it in half and just compare a single x to a single negative 1. So if, please show this work before we get out of here, you have time, we then get x less than negative 1. We find out x would have to be a value less than negative 1. All the way up to 2. You're still a minute early. You got plenty of time. Please make sure that's written down. For the bonus, if you want to know how the graph would look, the only point you actually have to reference is your negative 1. Open circle or closed circle? Open. Shade left or right. There's your graph. Have a great day, guys. Iron, feel better soon, dude.
Thank you.